Good morning, and this is just a shortish video which introduces your controlled assessment. We're doing controlled assessment for the next 2 weeks, and here's the reason why. The controlled assessment takes up 30% of your total GCSE. It's supposedly approximately 20 hours in length. I've already spoken about how that 20 hours is made up. We've got essentially 6 hours in the classroom, 12 hours on Wednesdays, 2 hours a week of home learning, and 2 hours a week of intervention on Thursday and Friday afternoons. Essentially what we're looking for is continual progress. The things that you need to do are listed in the syllabus, and this is the summary. You need to be able to show that you understand programming techniques. Now, by programming techniques, it means being able to perform loops, decisions, iterations, and sequence. Being able to assign things to variables and to use those variables in a program. To be able to design a coded solution to a problem, including the ability to develop suitable algorithms. Now, those algorithms can be displayed as a flowchart or as pseudocode, but need to be done in your design section. To design suitable input and output formats, which means that you need to be able to put design formats of data that go into your program and come out of the program. So I would suggest that input formats need to be as simple as possible, because users don't necessarily do predictable things, and output formats need to be as simple as possible. To identify suitable variables and structures. Now, variables we've already talked about. They're the boxes in a computer's memory that allow computers to store things. And structures would be things like lists and lists within lists. I don't think we need to do much more than a simple list in any of your assignments. Dictionaries might be useful, but if you don't know how to use a dictionary, stick to simple, stick to lists. And identifying test procedures. Now, we're actually quite good at doing the test procedures. Our test-driven development unit has been quite useful. Remember what we did in that unit. Remember that we're doing test first, then develop, and then test again. So making small incremental tests and making those and then going back to them. The smaller the test, the better. We need to be able to create a coded solution, fully annotate and develop code to explain its function. Notice the term there, fully annotate and develop code. In our last practice, we had a go at doing this, and yes, it's a little nauseating, but you've got the practice of this. You know how to do this. You need to be able to test your solution to show functionality. What that means is to make sure that it works, to show how it matches the design criteria, which means that you need to work out the design criteria. For each of the tasks, we need to work out, or you need to write down how you're going to know whether things are successful, and then you're testing for that success. Identifying successes and any limitations. The successes is where your program works. Limitations is when your program requires things to be in place for it. The word controlled has a special meaning. In a controlled assessment in computing, you may use references and help. Dr. Google is your friend. Just make sure that Dr. Google is telling you exactly what to do. When you use Google or Wikipedia or GitHub or whatever else you wish to use, you need to make sure that you put a reference in when you use these. Feel free to ask for help if you need help referencing. You may collaborate, which means you may talk to your friends about the work, but your work must be your own. You're okay to talk to people and to get ideas and to error check each other's code, but you need to say what help you got from people, and most of the work needs to be your own. I can explain the task. I can advise on resources and approaches. I can advise on how the task can be approached in general terms. I can't give you code. I can alert you to things that are required in the final piece, which is kind of what we're trying to do with this little video here. You may not disturb others from learning. This controlled assessment is almost a third of your GCSE. If you're coming in to talk about things other than programming, you are not helping yourself, you are not helping others. That is just the wrong way forward. You may not allow others to work independently without interference. That's the wrong way around. That should be you must allow others to work independently without interference. I may not comment on or correct your work. I can provide advice, but I cannot comment on your work, and I cannot correct your work. I cannot practice the task with you. We've already done a number of units that practice similar tasks, but I cannot practice this task with you, or any of these tasks. I cannot provide templates, however, we have done similar things in the past. I cannot provide model answers, however, the Python documentation provides model structures. Your previous work provides some model structures. I cannot provide feedback on drafts. You cannot give me a copy of your program and ask me to look at it. Okay, just to reiterate a bit of what they're looking for. This is from the syllabus unit, so I've got a little reference there. Don't reference like me, reference properly. We can go through that whenever you want me to show you, but have a reference there for me to. You should be able to identify and use variables. We've done these. These are simply things. Make sure that your variables all have lowercase letters to start with. Operators. So operators are things like plus, minus, times, divide, the modulus operator, the div mod. Inputs. Now that could be inputs as in arguments to functions or inputs from the user. Outputs. Again, outputs from functions and outputs to the user. Assignments. These are where assignments are where we put things into variables and get things from variables. Mostly put things from variables. Understand the three basic programming constructs that you use to control the flow of a program. Sequence, which is putting things in an order. Conditionals, which are if statements or if-else statements, and iterations, which are loops. So for statements and while statements. Understand and use suitable loops, including counting and addition controlled loops. Those are more your while statements, while iterations more your for statements. Use different types of data, including Boolean, string, integer, and real, or float, appropriate in solutions to programs. Real numbers are float numbers, integers are ints, strings are strings, Booleans are true and false. You've used those before. Okay. Don't worry about trying to get these into into your programs. They will happen naturally and organically. If they don't, then they don't. Understand and use basic string manipulation. Now this is something we have touched on before, and if you look in the documentation under strings and string methods, you're looking for the format specification. Understand and use basic file handling operations, open, read, write and close. Again, we've gone through these before, but not in very great detail. What you may need to do is just have a look in some of the Python documentation to give you a hand with that. Define and use arrays as appropriate when solving problems. Now, an array is a general term for a list. So when you see the word array, think list. It's like register and roll. Two words that mean the same. Design. Now, this actually needs to be a kind of section in your write-up, if you like. So in your design section, you need to analyse and identify the requirements for a solution to the problem. So when you read the task, you need to analyse the task, identify what the question is actually asking you to do. You need to design suitable algorithms to represent the solution to a problem, and write them down in pseudocode or a flowchart. You need to design suitable output and input formats and navigation methods for your system. That means it needs to be usable to the user. Identify the data requirements of the system, which means you need to look at the variables that you'll be using and you need to say what they will be doing. Identify suitable variables and structures with an appropriate validation for their system. Variables, we've already talked about, that's part of data requirements. Structures, so where you're using a list, why you're using a list, or if you're using a dictionary, why you're using a dictionary. Appropriate validation for their system. Validation is where your program does not allow a user to do something stupid. So you're telling the program how to do things to avoid user stupidity, if you like. Identify test procedures to be used during and after develop to check their system against the success criteria. Well, that's our test-driven development that we've been doing. The next section is your development section. You need to be able to develop a solution to the problem using a suitable programming language. Python is a suitable programming language. We can do that. Demonstrate testing and refinement of the code during development. So when we've talked about doing our test-driven development, that is what that is asking. Explain the solution using suitable annotation and evidence of development. Suitable annotation means commenting, and evidence of development means using a diary sort of format. Testing and evaluation. So you need to be able to use a suitable test plan and data, so test plan and test data, to test the function of the system. Test the system against the success criteria. So for each task, you need to identify the criteria that will make that you're looking for a successful system. To provide good evidence of test procedures, this could be printouts from your test functions and printouts to say that they're working, also printouts of your working system. To modify the system if required to meet success criteria if these are not met. So if your stuff fails or doesn't work, this is good. You need to record that it has not worked and then record what you did to make it work. It is better to do something wrong and correct it than to do something wrong and hide it. Evaluate the system against the success criteria to establish how successful or otherwise implementation has been. That is talking about how the system has worked and whether it's working or not. Again, this last piece of advice, you need to hand in at the end of this a single document, preferably in Word, containing 3 tasks. For each task in the task, you need to have a design section, a development section, and an evaluation section. Again, this is advice, you can do it as you want, but there needs to be clear and annotated design, development, and evaluation. The first task is a currency converter. We'll go into this one a bit more later on, but essentially the task is written down for you. You need to be able to exchange money between the 4 major currencies, and the 4 major currencies are listed as the pound sterling, the euro, the dollar, and the yen. The system should be able to change rate from the user, so you don't need to link it to a website that has the rates written in there. The user should be able to change them. The user should be able to enter an amount, select the chosen currency for this, and the currency into which it should be converted. So you should be able to convert yen into dollar, euro into pound, and in any particular way. Now, one way to make this slightly simpler is to use the pound as a base currency, and if you're doing a conversion between yen and dollar, convert yen from yen to pound and then pound to dollar in the same program, rather than storing the yen to dollar amount. The figure shown should be displayed to 2 decimal places, for example to the nearest cent in US dollars. Now the way you do this is you would use a string format. So look at the string formatting section in the documentation for help with that one. There's some sample data up there. To be honest, it doesn't really matter about the data you use because it's sample data anyway. I would tend to use very rounded off figures, so euros 1.2 to a pound, USD 1.67 to a pound, yen 200 to a pound. There's a couple of questions on there. I would possibly think about those in terms of guidance. You don't need to answer those questions, but they just need to. You need to be thinking about the skills on what to do there. Think about the symbols. Think about how you do the conversions before you go on write your program. Task 2 is the address book. The data file is supplied and it's on the wiki. The best advice I can give for task 2 is it's not a database. You don't need to make a database. It doesn't have to be a system, but it is like a database. Think about your data structures in task 2 and think about only doing what you are asked to do. Don't try and go too special on this, because it's a simple task that can be solved simply. You don't need to go too far on that. For task 3, this is a little bit more mathematical. I would suggest that you think about your test cases as the single digits, and that could help you with your testing. So think about those numbers as part of your testing schedule. I would perhaps work on some of those numbers, just working it through on paper before you start on the program, just to make sure that you know the process. Once you know the process, I would write down the process and then work from there. The tricky part of task 3 is going to be getting the algorithm done. Bit back to general advice. Remember our testing stuff. Test first, then develop. So red, the test fails. Green, the test passes. And then refactor. Change as you need to, but change as little as possible. Everything about Python is in docs.python.org. Yes, this is hard to read, but you can. The examples in there are good, and you've done lots that you can work back on. Use the work we've done so far. Use the last unit really well. Use the other stuff that we've done over the last 6 months. You have learned enough to do this. You just need to get a bit of confidence and go back and read your own work. There is a Year 9 Python course, which is a fairly easy to read tutorial. I'll find out the web link for that, but there's a couple of issues accessing that through the school system. And finally, just a bit of confidence. If you come into this saying, I can do this, you will probably be correct. If you come into this saying, I can't do this, you will again probably be correct. Most of this is about positive mental attitude. You think you can, and you will. This is about getting success, not trying to point out your weaknesses. You can do this. We can do this together.